everybody. February 25th, 2020. This is the remake of the Cascade Fire Slide Rule nozzle discharge calculator for determining flow and friction loss. One of the things that I'm going to start off with is showing you the face of the slide rule right here. It's in two parts. Now, most of you that are lead engine operators and qualified ENOPs and captains, this is really not for you, although this is intended for people that are just coming into the engine operator scene and are going to go through an academy or have gone through an academy but may not know how to take full advantage of this slide rule, which is really a nice, handy, and accurate piece of equipment to use. So with this, before I get into anything, I want to tell you that it's designed for smooth bores, but you can use it with combination nozzles. Now, the Forester, as you know, is counted as a smooth bore, so we'll use 50 psi nozzle pressure coming out this area here. But also, this is a smooth bore, what we call a play pipe, but it's also going to be used anywhere with 50 to maybe 80 psi of pressure. And then when you get into the combination nozzles, which is more like this 1-inch NPSH, the way that we determine what size to use is that on combination nozzles, such as what you see here, would be a combination nozzle because it combines a fog pattern wide angle with a straight stream. So how they determine the size is that when we say inch and inch-and-a-half combination nozzle, we're referring down here to the hose connection size when we say 1 inch and 1.5 inch combination. But when you get up into a smooth bore, it no longer has anything to do with the hose connection size. It's all about the tip size. So just keep that in mind as we go through these things. But getting back into the calculator, the proper way that you use this is you first of all want to determine which nozzle type you got, whether it's a smooth bore, a Forester nozzle, or a combination. So let's start off with what the Firestream calculator was designed for, which is smooth bores. So let's go back to this. So here you can see that we've got the smooth bore, and down in the bottom you can see here that the straight stream tip options are 3/16, 3/8, and 1/4 inch in diameter. So now right off the bat, if we go to our calculator, we know that the Foresters are at 50 psi nozzle pressure. That's where you're going to set your nozzle pressure at. And then what you're going to do is you're going to look at your tip size. And so the tip size is, we'll say it's 3/16 of an inch. So right off the bat, you're going to have 7.2, 0.4, because each one of these is a 0.2 gallon per minute rating in between the 7 and the 8. So you got two lines, so 7.4. So that's what it would be, 7.4 gallons per minute on a 3/16. But if we left the 50 psi the same, and let's say we change tips to now a 3/8, we would be flowing at the same nozzle pressure about 29.5 gallons a minute now. And if we had a 1/4 inch tip, we would be flowing 11, 12, 13 gallons a minute. So you can have the same nozzle pressure, but depending on the size of the orifice or the tip that you have on it, these are the corresponding flows that you would have under 50 psi. So likewise, let's say that we do a little experiment here. We've got the same Forester nozzle, but we're going to crank this up to 75 psi at the nozzle, and we're going to have that same 1/4 inch tip. Well, now we're going to get 16 gallons a minute. And if we had a 7/16 inch tip, we would be right at about 49 gallons a minute. And that's how that would work. So this is what you do with this. So set your nozzle pressure at the arrow, then read the discharge over the nozzle. So these numbers right here correspond to the nozzle pressure, and then the middle set of numbers corresponds to the gallons per minute that will be flowing, and then the bottom set of numbers refer to smooth bore internal diameters. That's what these numbers represent. So how that would work on a combination nozzle is you have to look at your nozzle. Most of these are designed to flow their rated flow at 100 psi nozzle pressure. So how that would look is that you would have this nozzle here, but then if you wanted to do your testing, you would plug in an inline pressure gauge right behind it and then connect your hose behind that. And so you would just throttle up and produce more flow until the nozzle was showing a pressure reading of about 100 psi. And then you would look at how much flow you had coming out, and then you would time it to make sure that you're actually getting it, because on a combination nozzle you're only going to get the true flow of, let's say, 25 gallons a minute if it's on a straight stream, basically opened all the way up. So if you shut this down like 10 gallons a minute, that's telling me that that's probably going to be closer to a wide angle fog. 25 is going to be a straight stream, 20 is probably going to be closer to a narrow fog or a medium fog, and then 20 is a narrow fog, and then 15 is even narrower than that. That's what that's telling me in my mind. Now that may not necessarily be accurate, but that's how I would look at that. So this is a combination nozzle. So when we get back into this, one of the things that you're going to want to do is set that for 100 if the nozzle's rated for that. Again, pay attention to what the manufacturer says. If it says, like the standard IRPG numbers, that for a variable pattern nozzle, 1.5 inch, you get 60 gallons a minute at 100 psi. Well, then what you would do is you would come over here and do the 100, go down to where 60 gallons a minute is, and put a mark in permanent ink under the 60. And then, because the 1 inch combination nozzle is set the same way, 20 gallons a minute at 100 psi, what you're going to do is leave the 100 alone, come over to 20 gallons a minute, and put a mark on the non-movable side so it looks like this right here: 100 psi, 60, and 20. What that will allow you to do is that if you get to a situation to where you have to string out 1,000, 1,200, 1,500 feet of hose, you're going up a little bit of a hill, and you've got a combination nozzle up there, and you do your calculations, say, you know what, I want to be like 40, 50 psi short on the nozzle pressure, so I don't think I can do the job. This is where you have to base everything off of your tactical objectives and look at the situation. If your tactical objective might be something to the fact of, let's say just you've got a very creeping burn. It's kind of like just creeping and smoldering, almost in a mop-up phase, but you just need some water up there. Well, then if you're 40 psi short, so let's say you're at 60 psi is what you're left with, and you've got that number, which is about where this would be, you'd be at about 42, 46 gallons a minute. So you're not getting the full 60, but if you just need to do mop-up, you don't need the full 60 gallons a minute, and therefore you don't need the full 100 psi nozzle pressure. The same thing would go for the 1 inch nozzle. If the 1 inch nozzle was out there and you were, again, only at 60 psi nozzle pressure, you might only have, let's say, 15 to 15.5 gallons a minute going out there. Again, if you're just doing mop-up, it's not a big deal. You can certainly do that. You don't need to be fixated on the 100 psi nozzle pressure for the combination nozzles, and you certainly don't need to be fixated on the 50 psi for a smooth bore, unless it's critical that you have that amount of flow to meet your current tactical objectives. So, as far as the accuracy in the Firestream calculator is concerned, if you were to go to the website wildfireengineer.com and then scroll down to where page 26 is, 27, you could use the tried and true and proven actual formulas and calculate it out by pencil, paper, and calculator, and take your flow, your nozzle pressure, and do the math, and it would tell you the right size diameter of orifice that you need to produce that flow at that nozzle pressure. Or if you didn't know what the nozzle pressure is, but you knew what the gallons per minute was and the diameter, it would then tell you what pressure to use. So these numbers are used to produce this calculator. In fact, if we enlarge this and I slide over the side, you can see here that we have the hose sizes here, and then we have our hose coefficients for each size. And then up here at the top on this left side here, you can see where it's talking about it's based on C, where C is a coefficient. When the friction loss equals the coefficient times the gallons per minute divided by 100, you get the quantity of that. Then you square it, multiply it by the coefficient, and then that will give you a number. If you then multiply that number by the entire length of the hose lay divided by 1, which gives you the number of sections, you come up with the friction loss, which, if you go back to my booklet, my quick reference again, you will come to on page 4, I think it is, page 6, page 7. The friction loss calculations, there's the coefficient number, substitute the actual number, same exact equation. And then the hose coefficients are on page 15 of the booklet, again, wildfireengineer.com. So this here is in the booklet that you can have on your phone, on your iPod, no matter where, or iPad, no matter where you go. And you could always back up and do a double check if you were ever to doubt what this thing is saying. This Firestream calculator is extremely accurate, so you don't have any problem using that. And when you're in the field using the IRPG, page 87, these numbers right here are about as close to fact as you can get when you're in the field. Unless you are on a hose lay all the time to where this is what you're doing, you're probably not going to have a table of friction losses per 100 feet for each size hose and what the flow rate is. 5 psi is rounded, 15 is rounded. It's actually 12.6 psi per 100 feet, and the 30 gallons a minute on an inch and a half. That number's not really accurate. It's actually 3.2. They've rounded it. Now, there's some problems with rounding. I would not round. I would recommend against rounding any of these numbers. Use the actual numbers. And if you look at other videos that I've got up on the YouTube channel, you'll see why I say that. But at any rate, you can use it for combination nozzles if you put these marks here in permanent ink. So that way, when you start running over or under on nozzle pressure for a combination nozzle, you can look at these bottom indexes here that you've created and see where your new flow in gallons per minute is going to be. And then you could take those numbers and set them down here on the bottom for the friction loss, and then get what your friction loss is going to be. So now that we've got that out of the way, now let's go to the friction loss. So let's assume that we have our smoothbore nozzle, our Forester. We've got a 3/8 inch tip, and it's at about 28 gallons a minute, almost 29. And so let's just pick one. Let's just say it's 28 gallons a minute. So let's come over here to 28 gallons a minute. It's going to be about as close as I can get. Then what you want to do is you want to look down here, size of the hose, what trunk line or what line size are you using at the end of that nozzle. Well, if it's 3/4 inch hose and it's 30 gallons a minute, you can see that your friction loss is going to be just about 89 to 90 psi per 100 feet. And then the smaller it gets, higher. But on an inch and a half, you're looking at about 2.5, 6, 7, about 2.7 psi per 100 feet on an inch and a half. Now, if you had a really long line, a couple miles worth, and you were to divide that by 4, you would end up with the bottom number of about 0.65, 0.67, almost 0.7 psi per 100 feet. So once you get the flow from up here, you set that number down under this index. Then you come over and you read where your hose size is. And then if you got one line out, You go up. If you got 2 lines connected together, you go down and read the bottom set of numbers. And that's basically it. That's all you really need to concern yourself with. But you can use these for both smoothbore and combination nozzles if you remember to put these 2 indexes under the 100. And if you've got a nozzle that's different than one that's ready to flow the 60 and 20 at 100, then maybe have a second Firestream calculator and write in permanent ink up on the top someplace for a task force tip or whatever it may be. And so let's say it's ready to flow 80 gallons a minute at 100 psi. So instead of having your mark here, put your mark under 80. So that way, if the same situation arises and you've got to go out 1,500 feet and up 200 feet ahead, and you're going to run shy on nozzle pressure, you can sit here and then slide this over and go, okay, well, this nozzle's not going to have 80. It's going to have, let's say, 40 gallons a minute or 30 gallons a minute. Again, it's not a concern if you run under the nozzle pressure. Just keep in mind that you're only going to have a limited stream, but you're also going to base this off of your tactical objectives. So again, if your tactical objectives are just that of mopping up or light work, it's a non-issue. And that's it. And thank you. We'll see you next time.